Hello everyone, Code Purpose here. We are going on with our tutorials on CodeChef Beginner exercises, and our next exercise is first and last digit, which is the ninth one in the row, the list. It asks from us to write a program that for a given number will calculate the sum of the first and last digit. So if we read 123, the sum of the first and last digit would be 1 plus 3, and it will be 4. So as output we need to get 4. And just let's read the input rules. The input rules says like this: we read an integer t, which represents the number of total cases, and for each case we need to read an integer n, for which number in new lines we will output the sum of the first and the last digit. As constraints, we have the number of test cases is between 1 and 1000, and the number of the number which will be read in each this test case would be between 1 and a million. So there are two solutions in this case, because we have constraints where we know n would be between 1 and a million. We can use brute force to solve this exercise using if-else statements, but we can do an universal algorithm that will work for every case. Let's start with the brute force, test it, and after that we are going on with our perfect solution, making an algorithm that will calculate the result. So firstly we need to a variable t, the number of test cases, and a variable n, which variable we are going to read in each test case and output the sum of its digits. So firstly we read the t, number of test cases, and we say while t minus minus, unless this t becomes 0, do the following commands, including the brackets. This is a post decrement. Firstly it returns the value of t, after that it decreases by 1. Let's go on. In each test case we need to read n, and you know that if the number is less than 10, then the result is n plus n. Why n plus n? Because we have only one digit, and that digit is the first and the second one. If the number is two-digit number, the number is greater than 9, and the number is less than 100, then we know that there is a rule. When we are talking about last digit, that's the simplest problem that we can get. The last digit we can get it easily using the modulus operator, which where we are going to use n model 10. So while dividing by 10, we get the remainder, which is the last digit. And to get the first digit in this case, which is a two-digit number, we just need to erase the last digit. In this case that is only one digit, and we can do that using the dividing operator. And in this case we divide by 10 because it's only one digit we need to get rid of. After that we get an integer number here because it's integer divided by integer, which is an integer. The compiler ignores the decimal part. After that we have if n is greater than 99, and if n is less than 1000, then the number is three-digit number. And again we have the same formula. The last digit is n modulus 10, but the first digit we need to remove two last digits and we get the result. We need to repeat this until we reach a million. So like this, if it's greater than 999 and it's less than 10,000, then we need to, the last digit is the same, we need to remove 3 digits, for example 978. We need to remove the last 3 digits and we get the first digit. After that, if the number is 5-digit number, if it's greater than 9,999 and less than 100,000, there we need to get rid of 4 digits and repeat the same also for a 6-digit number, where if the number is greater than 99,999 and it's less than a million, then the last digit would be the same mathematical operation, modulus 10, but the first we need to get rid from 5 digits. That's why we have here 5 zeros. So, and the last case, because it's least equal than a million, if n is equal to a million, then we can see out 1, because we know that 1 plus 0 is 1. And if we test this, let's copy this and check if it will work. Paste and hit there, enter. Oh, let's input them manually. Let's see what happens. You have 3 and 1, 2, 3, 4. We get 5. 1, 2, 4, 8, 9, 4. We get 5. Yeah, that's correct. 2, 4, 2, 3, 2, 3. We get 5 again, because 2 plus 3 is 5. Let's test this here. This is a brute force solution. Well, from this brute force solution, if maybe some of you got pattern there from how to solve this problem, and yeah, it's perfect timing of 0.00 seconds of running. And let's go through with the algorithm that will work with each number. Let's go like this. We can see that if it's only if we need the last digit, we can get it and modulus 10 in each if. And if we check the first digit in each time, firstly, let's say here we had n divided by 1, then we have n divided by 10, after that by 100, 1000, we just get one more 0. So because we don't know how many digits has the number, we can do something like this. We write it this way, and because we need to save only one digit, the first one, we say while we have more than one digit, divide the number by 10 and erase the last digit. So if we had a number 1528, firstly we get rid of 8, then of 2, then of 5, and we get the first digit. So we just output this time last plus and a new line. This solution should pass also, and that's it. Okay. Oh, time limit exceeded because we have while in while, and because there are a lot of test cases that makes problem. Okay, we just to know that there's another solution which works always, but it's not as perfect as this, because here we have just comparison, and that's faster than using a while cycle. As I said, the comparison is faster than the while cycle, but shouldn't make big difference. Oh, I made a mistake. Sorry to all. While explaining, I said that the while cycle should continue until we get a 1-digit number, and I made the opposite. While the number is 1-digit, then go on divided by that. I think that's the problem why we got time execution error there. Now I think it should work good. Let's just check it. Okay, 1 2 3 4. Okay, 1 2 4 8 9 4. Yeah, it's good. Let's check now if it works. Okay, submit once more. I hope really that was the mistake. We are all people, we do mistakes. Oh yeah, that was the mistake. Sorry guys, once more. It's good we fix it. As I said, this algorithm is a powerful one, and it is used to find the first digit of no matter how many digits has a number. Let's end this tutorial. Thanks for watching, and if you are new, make sure to subscribe by clicking the red button right below the like button. You can also turn on the notification by clicking the notification bell to not miss the upcoming videos. Thanks for watching once more. See you soon again. Code Purpose.